Hey everybody, thanks for clicking on this video. Today we're going to be looking at boundaries of sinusoid functions. If you want to follow along, the links to the companion worksheet are in the description below. Also, if you want to see more videos like this, click the subscribe button so you can stay up to date on all the videos we have coming out from this channel. Now the idea of boundaries of functions. Well, we know that all of these are basic sinusoids. So they're going to look like this. But the question is, what's the top? And what's the bottom? Well, we know where the middle is. That's the vertical shift. So for a sinusoid like this, it's going to be 7. And the amplitude is 2, so that means the high is going to be 9. And the low is going to be 5. So those are the two boundaries. If we were to graph the line y equals 9 and y equals 5, this graph would fall in between it. Now what we can do is we can generalize that rule to here, where we can say, well, what if it's a sine of b, a sine of x plus b? So we still have our graph, and our vertical shift is b, and our amplitude is a. So that means, what's this? Well, we go from b and we go up a units, whatever it is. So it's b plus a. And then we go a units down from b, so that's going to be b minus a. And so those are the two boundaries, whatever they are. Now the important thing to keep in mind is that we can apply this even if a and b are not numbers. Because everyone thinks when they see this that a and b have to be numbers. Well, actually they don't. As a matter of fact, they could stand for multiple terms. So if I look down here, if I just follow the logic, I just say, well, what are the boundaries going to be? Well, this is b right here, and this is a. So my two boundaries are going to be -4 plus x and -4 minus x. We don't have to worry about the fact that, wait a minute, this is not a number, this is a variable. That's okay. This rule still works. So that means what we're going to have is we're going to actually have two lines that crisscross each other. And so this graph is going to produce a sinusoid very different than ones like this. But if you have a graphing calculator, or if you want to go graph it online, go take a look and see what it looks like. So here we got a few more we can practice with. So here we have -4 sine of x plus x. So our boundaries are going to be, we start here with x, and then we add the amplitude, so it's x plus 4, and then we start with the vertical shift, and then we subtract the amplitude. So x plus 4 and x minus 4 are the two boundaries for this function. Now with number 5, if we treat this as the vertical shift, and we treat this as the amplitude, then what we have is we have cosine of x plus 7 and cosine of x minus 7. But remember that addition is commutative. And because of that, I could rewrite this like this. Cosine of x plus 7 sine of x. I could treat this as the vertical shift, and I could treat 1, because that's sitting there invisibly in front of cosine, as the amplitude. So actually, I could also treat this as my set of boundaries. 7 sine of x plus 1 and 7 sine of x minus 1. I actually have two sets of boundaries here, and both of them fit this one function. So if you want to graph this, graph these two boundaries first, and you'll see that it fits between them. And then graph this with these two, and you'll see that it fits between those as well. Now for this last one, notice that we don't have a vertical shift. So you could think of it as just plus 0. So the two functions that it fits between are 2 to the negative x and -2 to the negative x, because we're adding and subtracting these from 0. So this is how we find the boundaries of functions. We take the vertical shift and then we add and subtract whatever the amplitude is. Thanks for watching. If you liked the video, please give it a thumbs up. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the best way to understand something is to do it.